two projects. In this video, we are going to explain about detecting SARS CoV-2 from chest X-ray using artificial intelligence. Introduction. The project explores the use of chest radiographies, X-rays in conjunction with deep convolutional neural network (CNN) methods to detect and diagnose the development of COVID-19, which is caused by the SARS CoV-2 virus. 6 updated deep learning models for detecting SARS CoV-2 infection from chest X-ray pictures are proposed and tested in this project. Using a small and balanced dataset and a bigger and imbalanced dataset, the project examines the result in terms of accuracy, precision, recall, and F-score. The project also includes a pilot evaluation of VGG16 models on a multi-class dataset, and the project demonstrates that the recommended methods are a feasible and accessible alternative for identifying COVID-19 patients. Objective. The project's goal is to develop and evaluate 6 modified deep learning models for detecting SARS CoV-2 infection in chest X-ray pictures. Using a small and balanced dataset and a bigger and imbalanced dataset, the project examines the result in terms of accuracy, precision, recall, and F-score. The project's goal is to propose a successful deep learning based screening approach for detecting COVID-19 patients from X-ray pictures, ultimately presenting a realistic and accessible option for identifying COVID-19 patients. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload COVID Images Dataset. This module involves obtaining a dataset of chest X-ray images, some of which contain SARS CoV-2 infection, COVID-19, while others represent non-COVID-19 cases, normal or other lung diseases. The dataset is essential for training and evaluating the AI models. Second module is pre-processed dataset. The dataset needs to be pre-processed before feeding it into the AI models. Pre-processing involves tasks like resizing the images to a consistent size, normalizing pixel values, and splitting the data into training and testing sets. Third module is Train Inception Algorithm. Inception is a popular deep learning architecture known for its effectiveness in image recognition tasks. In this module, the AI model based on the Inception architecture is trained on the pre-processed chest X-ray images to learn to distinguish between COVID-19 positive and negative cases. Fourth module is Train ResNet 50. Fifth module is Train ResNet 100 algorithm. Sixth module is Train VGG16 algorithm. Seventh module is Train VGG19 algorithm. Similar to training the Inception model, these modules involve training different AI models based on ResNet 50, ResNet 100, VGG16 and VGG19 architectures. Each of these models learn to classify chest X-ray images into COVID-19 positive and negative categories. And the 8th module is VGG16 Confusion Matrix Graph. After training the VGG16 model, a confusion matrix is created to evaluate its performance. The confusion matrix displays the true positive, true negative, false positive, and false negative values, providing an assessment of the model's accuracy and ability to correctly classify COVID-19 cases. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. In the dataset folder, we have COVID folder, in which we have the X-ray images of the COVID infected people. And this is normal folder, in which we have normal X-ray images. This is the model folder. This folder contains pickle and .h files stored, which contains algorithm information. These pickle and .h files can be loaded into the project code during runtime to utilize the train models. DenseNet, Inception, ResNet, VGG16, VGG19, these are the Python files which we have used in the main code during the execution of the project. This is main code file, this is run.batch file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. So this is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on Upload COVID Images Dataset to upload the dataset. Select Dataset, open. So we can see that the dataset is loaded. Now click on Pre-process Dataset to read and normalize images. So after pre-processing the dataset, we will get the processed images. This is one sample process image. Now close this image. Now click on Train Inception Algorithm to train the algorithm and get its accuracy. After training Inception, we will get its precision, recall, F-score and accuracy. And this is the Inception accuracy and loss graph. X-axis represents the epoch, Y-axis represents accuracy or loss, and the green line represents accuracy and red line represents loss. With each increasing epoch, accuracy increases and loss decreases. Now close the graph. Click on Train ResNet 50 algorithm to get its accuracy. After training ResNet 50, we will get its precision, recall, F-score and accuracy. And this is the ResNet 50 accuracy and loss graph. X-axis represents the epoch and Y-axis represents accuracy or loss, and the green line represents accuracy and red line represents loss. With each increasing epoch, accuracy increases and loss decreases. Close the graph. Now click on Train ResNet 101 algorithm to train and get its accuracy. After training ResNet 101, we will get its precision, recall, F-score and accuracy. And this is the ResNet 101 accuracy and loss graph. The x-axis represents epoch, y-axis represents accuracy or loss, and the green line represents accuracy and red line represents loss. With each increasing epoch, accuracy increases and loss decreases. Now close the graph. Click on Train VGG16 to train and get its accuracy. After training VGG16, we will get its precision, recall, F-score and accuracy. And this is the accuracy and loss graph of VGG16. X-axis represents epoch, y-axis represents accuracy or loss, and the green line represents accuracy, red line represents loss. With each increasing epoch, accuracy increases and loss decreases. Close the graph. Now click on Train VGG19 algorithm to get its accuracy. So after training VGG19, we will get its precision, recall, F-score and accuracy. Now click on Train DenseNet algorithm to train the algorithm and get its accuracy. After training DenseNet, we will get its precision, recall, F-score and accuracy. And this is the DenseNet accuracy and loss graph. X-axis represents epoch, y-axis represents accuracy or loss, and the green line represents accuracy and red line represents loss. With each increasing epoch, accuracy increases and loss decreases. Now close the graph. Now click on VGG16 confusion matrix graph. So this is VGG16 confusion matrix graph. X-axis represents the predicted class and y-axis represents true class, and the yellow and this light green color represents the correct prediction and blue color represents incorrect prediction. Now close the graph. And the final conclusion of the project is the project concluded that the deep learning models VGG16, Inception, ResNet v2, ResNet 50, MobileNet v2, ResNet 101 and VGG19 can detect SARS CoV-2 infection from chest X-ray images. On both balanced and imbalanced dataset, the improved VGG16 and MobileNet v2 models can classify patients with COVID-19 symptoms. Healthcare professionals double-check the model outputs to ensure that the results could be validated. The initiative highlights the promise of artificial intelligence-based approaches in combating the present epidemic by employing diagnosis algorithms that function reliably with easily available data. such as chest radiography. Some of the project's drawbacks can be addressed by doing tests with highly imbalanced big data and comparing the performance of the methods.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.